What's up, everybody? Welcome back to the stream. So today we're going to be picking up where we left off the last stream, which was we're going to be doing RE on the Hinge part, which is a part that is part of a larger project for a client. So we're just going to be doing RE on that. If you guys have any questions, we're going to kind of keep it the same format as last stream, where I'll be doing work in the beginning, and then as you guys have questions that kind of come up or anything you guys want to address, we can kind of pause that work and then go tear into that for a little bit. Probably be streaming for like an hour today, maybe an hour and a half or so. So whatever we get in, we'll do. But yeah, looking forward to hanging out with you guys. Last stream was awesome. We had lots of good questions. We got into like some good specifics of like top-down modeling and some equation stuff and variables and all kinds of cool stuff, and got some really good answers for people. So today, if you got questions, feel free to reach out. Just leave them in the chat, and we'll kind of go from there. And thanks for hanging out. All right, so let's get into SolidWorks. So we're going to open up the previous file. All right, so let's take a look at what we have as far as what we did last time. All right, so we have created an assembly file, right? Because obviously it's an assembly, it's got more than one piece to it. We created this part 9 up here, which is going to be the part that holds all of our skeleton sketches, right? So it's all of our base sketches are going to go in here. And then just as an example, as part of last stream, we made this block and pin just to look at different ways of creating geometry off of those sketches, and how to like control gaps and tolerancing. So we'll probably delete these. And you can see that that's one of the strengths of like skeleton sketching or top-down modeling, good modeling practices right there, right? We just deleted an entire part out of this assembly, and our feature down here didn't break, right? Because it wasn't referencing any geometry in that part, so we can take them out, put them back, and not have our trees explode and get all angry. All right, so we'll isolate this and go and edit it and look at the sketch. So these are like the base measurements that we had off of last week. So we were looking at the motion, I believe, is where we kind of left off on it. And we're just kind of dragging this around and looking at what happens. Now, we want this top line here to be more or less, I believe, flush with the top of this when it's in the closed position, which is this position here with both of them horizontal. And so we're obviously off by quite a bit here. So that could be misalignment in where the pins are or where this part is. So we're gonna go back through and double check our measurements and see where we might be off at. And it could just be that one of our arms is the wrong length or something like that. Or it could just be the fact that when we were taking our measurements, we kind of made some rounding to try and get whole numbers. And it could be that those rounding errors just compound on the mechanism to not quite line up where we wanted to. So we'll take a look at it and go from there. If you guys have any questions, for sure, leave them in the chat. If you guys want to change topics or anything like that, or have any questions about the workflow that I'm using. So we'll go from there. All right. So most of what I'm measuring today is just going to be caliper work. So I'm just checking dimensions that we have from last time, making sure that they are that they're accurate. Everything looks good so far. I'm tweaking this a little bit. Now, one way that we could do this, if we weren't trying to reverse engineer what was here, is when you're doing a 4-bar linkage, you can kind of use SolidWorks to help you design or figure out what your lengths are. And that's actually a really good way to do it, because you're able to set your beginning and end points in SolidWorks, and then you can let SolidWorks calculate what your in-between links are from your ground. Everything looks good so far. All of our links look like they're the correct length, so it might just be the relationship of the ground points to each other. Maybe we change this a little bit. So if we fix this as horizontal, right, everything is going to go and be fully defined. And so really it's this height here that we're trying to figure out where our measurements are off so much that we're getting this almost 3/8 difference in what the model is compared to what we have in hand. And I suspect that it's just the rounding errors, or the rounding, not errors, but the rounding adjustments that I made to get whole numbers based on what the hand measurements are. Like, for example, this 2" 750, which in part is defining where these locations are, is actually 2" 773, right? So it may just be that compounding of errors over the adjustments. Okay. I know watching me measuring stuff isn't the most entertaining, so if you guys have questions or want to change topics, like I said, feel free to type in the chat. This almost looks like a 2.45. Yeah, so that seems to help a little bit. So this might be a good time to mention, in the previous live stream, somebody went in and commented that they prefer the edited down videos to the live stream content, which personally I agree. I think that the edited videos are much more to the point, much more interesting to watch. They have they definitely have better focus, and as far as like learning something immediately, they're definitely the way to go. So my explanation and my reply was basically, I have to do client work, and that's taking a majority of my time right now, obviously. And so since that's what's currently paying the bills, that gets priority. But as far as doing an edited video versus a live stream, if I can do some work while doing a live stream and interact with you guys, I think that to me is valuable. Or and maybe it's not to you guys. Maybe you'd rather just have me put the time into the edited videos. But to me, being able to work and interact with you guys and kind of just touch base and see what type of videos you guys want to see, what topics are you guys asking questions on, and then either address them in the live stream and use that as the raw footage for the edited down videos later, or just me taking notes and saying, okay, they keep asking about equations, or they keep asking about top down, or they keep asking about surfacing or STLs, or whatever you guys want to talk about. Being able to interact with you guys and get live feedback on the people that are engaged with the channel, to me is valuable, in that it'll help me make better edited videos later, because I'll be able to specifically nail the topics that you guys have been discussing or want to discuss. So that's kind of the theory I'm going on, based on doing a live stream versus putting out an edited video, trying to get basically interaction and take the temperature of what you guys want to see, while also doing some work, and then just kind of going from there to see whether we pivot back to just live videos or just edited videos versus doing live, or a mix of both, or the live stream ends up feeding the edited videos and we just kind of make clips out of it later. So let me know what you guys think as far as like what strategy you guys would prefer and the content you guys prefer to see on the channel, and we'll kind of go from there and see what happens and see what you guys want to do. But yeah, and he apologized for saying, this isn't, he doesn't want to be like me to take offense to it, and definitely not. I mean, I can see where the advantages of both types of content are coming from. So if you guys have any type of feedback you guys want to give me, by all means, I mean, good or bad, I think I have thick skin, but it is the internet, so who knows. Yeah, so feel free to let me know, like good and bad, what direction you guys want to see this go, because really I'm making this stuff for you guys, so you guys are definitely a part of it, and so we'll kind of go from there. See what this does. Kind of takes me back the other direction.
Everything looks good. We're just slightly off somewhere. So there's one thing to be careful of. So if you guys notice, I just drew this line, right? And it automatically was fully defined. And when you're drawing your sketches, there's SolidWorks will try to help by putting in relationships to things, right? And when the sketch is simple, like if you're just doing a circle or a square or whatever, it's not the end of the world. But when you're doing top-down modeling, you're kind of putting a lot of information inside of sketches sometimes. And so you have to be careful when you draw geometry to really pay attention to whether or not these, like this was an obvious one because I drew a line and it was fully defined, right? I hadn't dimensioned where that line should be, and so it was easy to pick up. But as you're drawing more complex sketches, and obviously you're trying to keep them as simple as possible, as much as you can. But as you're drawing things, especially if you're trying to do like motion or something like that, like what we're doing, really paying attention to when you create geometry, is it behaving the way that you want, right? And a good way to test that is to kind of draw something and then try and move it. And is it pivoting around? Is it just moving through space and staying square? That'll kind of give you insights into maybe SolidWorks snapped to something that you didn't necessarily want. And there's a way to remove that in settings. I can't remember what the setting's called, but you can basically stop SolidWorks from automatically creating relationships. And so if that is something that's a problem for you, it might be worth it to go in and turn that off. But just something to keep in mind as your sketches become more complex and as you're trying to build relationships, right? Especially the way that I model. A lot of my driving numbers or my driving geometry is relationship based, right? Like we talked about last week, how instead of we wanted these circles to be, symmetric across this plane. So instead of knowing what the distance is and then going in and prescribing some distance, or maybe even creating a dimension here and putting it as half of this dimension using an equation, instead we just put the center point here, we mirrored the center point across and then made it vertical, right? And that to me is a cleaner way of doing that, because it may not be cleaner necessarily. I mean, I think it is cleaner than prescribing a dimension, but the bigger difference to me is that SolidWorks seems to update the geometry and play with relationships a lot more consistently than it does with dimension driven things. So like SolidWorks will always solve this geometry to be correct, but variables and the way that variables update may not always be correct. So or may not always be most up to date. You might have to like exit the sketch and rebuild to get the variables to kick over and whatnot. So I found working with geometry and relationships and stuff like that, constraints is much better than trying to drive stuff through dimensions. All right, so let's see here. Something's still off. So keep looking for that. And it could be, yeah, so it could be that dimension that we made. So we're going to remove this, make this driven. And we're gonna, I was assuming, well, I know that the ultimate design that we want to have is where these holes are equally spaced within this material, right, from the edge. But that was an assumption that I made up front. Maybe we make this driven as well. instead of trying to measure across from center line to center line, let's try and play it like this and see what we get. So it's a little bit closer to what it was. And I wonder if I just slowly start taking out our estimates. Now, ideally, if this is going to be a purchase part, you just contract the manufacturer and get CAD from them. Because then you'll be correct to their specifications, which is really what you want to be. So now I'm just going in because we're still off, even though the dimensions seem to be what we want them to be. So now I'm going in and punching exactly what we get measured as. And hopefully that will help clear up what the issue is. Yeah, it's just those little adjustments, I think. That's what's been messing us up. That's pretty good. Yeah, that's looking much better. So it seems like it was just those little adjustments that I was making to try and make everything perfect that actually ended up being our downfall, or the reason that we had such a discrepancy in the gap. Yeah, with making even those little changes, we're looking a lot better. Okay. So I think we'll probably leave it like that. Once again, so we had added a horizontal relationship to lock everything down, but when we drew this line, it came in as horizontal and was added automatically, which was fine at the time. But what we actually want is this to be free. And now that we have the dimension on here, it'll control the fact that these two are parallel to each other. So we'll be able to move things properly. But you could see that we removed that horizontal that was originally controlling this. And now, and it stayed fully defined because there was another horizontal automatically added to this that we had to remove. So as you can imagine, as your sketches get larger and more complex, those little relationships become harder to find. So it may be advantageous to turn off the like auto relationship stuff. All right, so one of the features of this part, or of the hinge, is that the motion is constrained by the linkages bottoming out on themselves. So the open position is defined where this pin here basically interacts with this arm. And then the closed position is defined where this pin here interacts with this arm. So what we're going to do is we're going to draw in the linkage widths so that we can determine where those locking points are. And this linkage here actually has a small bend in it. I don't know if you guys can see that in the video or not. But there's a small bend, so we're going to have to place that bend accurately to get the open and closed features that we want. So I'll probably draw in what the angle is here, just as to have some type of control over where we want the endpoint to be. And we'll measure that really quick. And we're just going to measure angles relative to each other. So it's around 78.5 degrees. Other way, actually. No, that's correct. Yeah, 78.5 degrees. Which seems like an odd number to make it, but we kind of got bit by the hole. So we'll make this like this, and then we can kind of gauge where this position should be. Actually, this might be a cool way to do it. Okay, so we're going to, this is kind of what I was saying before when doing 4-bar linkages. So since we know what the lengths of our arms are, and we're all within one sketch, we can draw our linkages again and set them equal to each other, and then define the start and end points that we want. And then SolidWorks will automatically solve it for us and kind of fill in the rest, which is nice. So what we want to do now, we'll probably set these guys to reference because they don't actually represent the bottoming out geometry. Probably don't need this geometry either. All right, if we fix this, ooh. So if we were to go in here and set this equal to 78.5, we can see where these links end up. Right. So let's see here, what would be the best way to do this? Actually, I'm probably gonna turn the equal constraints off, set them to collinear, and then turn the equal constraints back on, and they should snap to where they're supposed to be. So let's do that. And basically what I'm trying to get is I want these points to be in the right spot. Maybe that's the way to do it then. But I don't want them to end up being the same points. And if you use coincident, SolidWorks will compress them down to be the same points. Yeah, see, like it just got rid of that line. So if we take this off and we suppress this, we can move, and you'll see how that point is now fixed where we want it. So now we can fix this one, or at least control the angle of it. And again, this is almost made harder by the fact that we're trying to reverse engineer it as opposed to just designing it the way that we would normally. So we can see that when that hits that angle there, that's exactly what we want. So now we can bring the step back down here. And I believe if we set these all to equal, whoop, not parallel, we should get the alignment that we want at the end. So this, as this comes up, we can see that it passes through what we want as it comes around, right? And that's being controlled by that one link's angle. So that's the end position that we want. And then we can bring the step back down here and make this the start position. And now we know we have both the end and beginning, the start and the end position of the linkage. And that's what I was trying to say before, as far as creating links that are, or if you were to do this, not trying to reverse engineer it, right? You didn't really care what your links were. You just wanted to start and end point. What I would do is I would go in and draw my start point and my end point, and then draw my links to those, and then set them all to equal. And you'll be able to control your link lengths and your start and end point. Because really what you want is the start and end points controlled, not necessarily your links. But in this case, we're trying to control our links based on what the dimensions are, and then kind of like fudge and figure out where the finish there the stop locations are. Okay, so now we can put geometry on here. Well, this is basically going to be is, do I want to do this way? Probably, I suppose. This is probably an all right way to do it. So now this here will be the stop point for here. And I believe our linkages are the same thickness, so they'll have the same diameter. Yeah, it looks like they're both 1/2 inch. So we can make them the same size as this down here. And then this all ends up tangent to each other. And we'll end up the same diameter. So now we have our end location here. Now all we have to do is put our end location here, and it should be 1/2 inch from here. So if we did our job in theory, this will be 1/2 inch. It'll be 1/2 inch and tangent to that pin. Which is pretty darn close. On the grand scheme of it, how far off were we? 15 thousandths on the sheet metal part. So not too bad for just reverse engineering what we have in hand. All right, so now we know that this is good. We'll probably tweak this a little bit and make it actually make the stop here. So let's see here. How do we want to do that? Probably turn off its relationship to bottom and bring it down here. And the nice part is that since the way that we design this with these relationships is that this will all automatically update. And so our geometry will stay the same up here as it will down here. All right, so now that we have our base geometry, we can start making some parts. So we'll get out of here and we'll redo what we did. Like we deleted parts at the beginning of the string, and we're just going to add those parts back in, or recreate those parts, but create the correct geometry. So we're doing the skeleton sketch technique, which means that we're going to derive these sketches, or this sketch, into, actually, you know what, we'll do widths here first before we start doing this. So we will isolate this part, and then we'll do a front plane, and we'll get our widths in, and then we'll import, or we'll derive both the views, the sketch views. We'll derive both sketches in at the same time when we create the part. All right, so we're in the front plane. And really all we need are a couple dimensions here. So let's see here. We'll have something like this. And we'll have a shim, or we'll have a washer. We'll have our linkage. We'll have another washer, and then the other side of the sheet metal. Like that, right? Well, we can maybe offset these just to get cap ends, lines. There. Well, I should delete that. And we'll control this with the geometry that we already have. So this doesn't go here. This is going to be in line with this. And this will be in line here. And again, we're using that sketch geometry that we already have to establish or to control these dimensions. We don't want to put another dimension on here when we already have a sketch that has geometry that we can reference. All right, so now I'm thinking about where I want this plane to be, and we'll probably dimension to the larger, or we'll probably define it to the larger bracket. So we'll make this our right plane here. Again, we're not dimensioning things. We're going to create relationships. So we'll just make this equal. Collinear. Now this stuff is all going to come down and be collinear. But we do actually know where the center line of this is. It goes right through this point here. And then this collinear here. And we have a thickness for that shim, or for the washer. It's 3 seconds. And then this is our, actually this thickness here, we can make the same as this because the links are made out of the same sheet metal as the main brackets. And then we know that this actually goes on a different piece. It would go on one of these up here. Or this back here, either one. I'll just make it in the closed position, I suppose. And we'll make it in the open, I guess. It doesn't really matter, I suppose. Actually, where this ends up doesn't matter at all because it'll just be the width. But we'll put it up here. And this is collinear. And we can make this the same as this because we know it's all the same material. And this will be the same too. This is actually offset, so I didn't need to make this equal. I don't believe, yeah, because it's all offset geometry. So in theory, I could take this out, but. And now this will be equal to the dimension that we set over here, but instead of adding another dimension, we're just going to set it equal in width. There we go. Okay, so now we can look at some of the dimensions that we're missing, right? So for starters, let's see, which actually makes me want to bring this down now that I think about it. So we don't need this center line or this point, so we can simplify this a little bit. but we will take this out and move this down to here. Okay. Now we know what the width of these are based on that it's coming from this diameter, right? But if you notice, we can't add a tangency constraint necessarily to this, right? Which would be nice. So we've got a couple of different options. One is we could derive in the geometry. Or we can convert entities on it to get points in here. But as you can see, this is kind of like on edge, which I don't really love. So what we can do is maybe we derive in a different one, since we know these are all have relationships to each other in a different sketch. So we can just derive in a different one up here. And then make all of these equal. Now it sets that. Now our linkage, we know, is also 1/2 inch in diameter. Or in width, I guess. And we can put this here, that's fine. All right. Now this will be set over here. Right, and now we can see that everything's defined except for things that we haven't controlled yet. So we know that we need the width of this flange here. And then the width of the other flange as well. Now, another thing we could add in here, we know we have holes that go into the flanges. So we could start defining maybe where the center line of those holes are. Like the offset of those holes. So we can add axes that we can reference maybe in a different sketch later when we go to put the hole locations in. So this is a 1/2 inch from this edge. And these are actually closer to the edge than that. There we go. All right, so now we've got this. And now we can go back into this part here. I'll exit isolate. So we're going to edit this part and then isolate on this one, which will actually bring it in and then allow us to turn it off really easily. All right, so now we're just importing our sketches. Derived, right? Right plane, insert. It's the right plane. Oh, no, we want the front plane, sorry. Insert, drive sketch. Okay, Now, I did not locate this sketch to anything. We can exit the isolate, which will turn off that one part here. So I did not locate this, or have not defined where this sketch will be. And one of the things that we can do now is we can decide, do we want to model our parts in place, or do we want to model them so that our base planes are aligned in some useful way, right? So that's kind of the decision that that's kind of the option that we have to make now, or that is the decision that we have to make now. So what we can do is we can just leave this where it is. We can just attach this to, the origin, which I think this is probably a good origin. Like say we're making this bracket part down here, right? I think that's a fine spot for the origin to be. And then this top plane is probably fine to set parallel, right? And now we have it fully constrained. And you want to constrain to your ground planes usually in your origins, usually something within the sketch. So I think that's fine for, like, say we were making this bracket, right? But let's say we were making this bracket back here, right? We could use the same constraints when we're going to make this bracket part back here, but the front plane will then be up here and our geometry will be back here. Whereas if we wanted to, we could do something like origin. We can make maybe this the origin on the back piece, right? Now, the benefit of that is that your origin is now in a more useful location, like your base planes are more useful for this bracket back here. But when we go to add the part into an assembly later, and I'll probably model it the other way and show you guys how that works. But if you model all of the parts with the same origin and base plane locations, regardless of where the geometry is within that part file, when you go to import them into an assembly, all you'll have to do is click the green check mark and they'll all snap to the origin and they'll all be modeled in the correct place. So why don't we kind of take a look at that? So this would be the second way of doing it, where your base planes are more useful. But when you go to add them into an assembly, you'll actually have to go in and create mates, as opposed to all of the geometry snapping into, place when you go to import them into an assembly. All right, so let's do this, right? Okay, so skeleton sketching, we have these two derived, or top-down skeleton sketch method says that when we have our derived sketches in here, the next thing that we want to do is to create sketches that reference those sketches so that the two derived sketches that we have stay at the top of the tree. I know it's kind of like, to me, it's always like Inception. We're creating a sketch within a part that then's copied into another part, but then we create a copy of that sketch when we make a feature. And it's really just like the organizational structure, right? It seems like it's folders within files within folders, but it helps keep information readily accessible and in a very organized way, so that if you come back to this part in 5 years, or somebody else comes in to design on this part, if you both understand what the system is, you can look at the structure of the part very easily just from opening it up, right? So as an example, say we want to do this bracket here, right? So we want to make a extrusion, right? And we're going to select this geometry here, and we want to do from vertex up to a vertex, right? There we go, right? We have our bracket, but you can see that because I didn't create a second instance of that derived sketch, basically we'll create a sketch and then derive in the, or not derive in, what's it called? We didn't convert the derived sketch entities into the sketch. You can see that this feature now 8 and is hiding our derived sketch. So which is fine when it's only a couple of features, but when your core sketch is now hidden within your feature tree somewhere, it makes the next user, or it makes it difficult for you or the next user to come back and be like, oh, there's 2 derived sketches in this part. I can see where the geometry is coming from. So the better method to do it would be to go to our front plane and do a sketch, right? And now we simply select this loop, convert it over, and then extrude it. And you'll see how this one additional step makes the feature tree have a lot better structure. So now we can see there, whenever you open up this part, there's 2 derived sketches in this that create the geometry within this part. This feature, right, was made with this sketch now. So it's no longer hidden inside of here. And it's easy for anybody to open up and be like, okay, this is what is driving this part. This is what's driving the geometry here. And if you needed to make change, you would know, okay, I need to go back and I need to open the files that have these derived sketches and make the changes there. And then those changes will propagate to all of the brother and sister parts that we end up making. So now we can do a right plane sketch, and we're going to put holes in. We don't know what size holes we're doing necessarily, so maybe that's something that we would want to share across all these features, all these parts, right? Is what size of hole do we need for the rivet that we'd be putting in? So in that case, instead of putting the information in this one part, where it's only local to itself, we're going to go back up here and we're going to put that information in here in one of these sketches. So, and this is how your sketches get more complicated, right? Because you're, in a way, you're adding more information into a single sketch, but that sketch is being shared over multiple parts. So you're creating it once, but get to use it multiple times, as opposed to putting the information in each sketch separately across multiple parts. So now we'll use McMaster Carr probably to find a suitable rivet. Let's see here. So we can look and see what our material thickness is to find us a suitable length. And we know that our material thickness is going to run from this face to this face, which is almost 3/4. All right, now we can check the head diameter to figure out what diameter head we want. These look like they're 1/2 inch diameter rivets, which I don't see on McMaster. They have a 3/8. Oh, no, they do have a 1/2 inch. Okay, there we go. All right, and so the hole that we want to drill here is 199. All right, so now we know the hole diameter that we need across all of our parts. So we'll go in here, and that dimension is already, or that sketch geometry is already imported over, right? We can see that we have our hole here. So we can do this, and then just create another circle and set it equal. And now we can use this diameter across all of our parts and all of our holes, wherever we need to put them. So let's see here. We want an extrude cut blind through all. We'll do through all both just in case the geometry moves around, right? Whenever you can use a through all both, use that because it'll be the most robust feature. But be careful if you add geometry somewhere else that doesn't want to, that you don't want it to be cut through. Be aware of that as well, obviously. But it's better than using a blind or a up to a surface or up to body or something like that. Because then if your geometry moves or you remove that surface or that body, your feature will fail, whereas through all will always cut. You just have to watch and make sure it doesn't it cuts what you want it to. All right, so now we need the screw holes on the top here. So we're going to make a sketch on the top plane. And this time we're not going to import a, well, let's think about it. Should we do a derived sketch to show the screw hole locations of the part? Originally I was thinking no, because the screw holes are the only part that cares about the screw hole is the bracket that the screws go through. So we don't need that information shared across all of the other parts. But we do know that this part will be a sub-assembly in a larger assembly, right? So this is obviously a hinge that goes on a door. And so it may be useful to know where all the screw locations are for mounting this hinge within a single sketch, right? Because that might be some information that we can, or that might be a good like hole pattern sketch to have in the future when we're trying to put screw bosses and stuff like that, or drill holes or something like that in a future location. And so it may be useful to have that all within one single sketch. So I think that's what we're going to do. We're going to put it back up here, and then we're going to drive it down into these parts. And then we can change the whole pattern for the whole assembly within one sketch. So I think that's what we're going to do. We're going to exit out of here and delete. Yeah, we're going to delete it, and then we'll just recreate it when we come back in. So we'll go back up into our holding part. We have to come up with better names for these things. I don't know if there are proper names, but like this is basically this part is basically a folder that we put at the top of our tree that holds all of our reference sketches. Also, skeleton sketch is just entirely too long of a name for things. All right, so we're just going to put 2 lines in here for now. And we know where the location is based on these sketches. Like these points that we put in previously. So now the question becomes, where do we put these things? So we could do a center point and run them off of here. And now I know, depending on where they go, they'll be centered across this bracket and located correctly when we go to put them in. So we can do a similar thing back here. But we don't have this geometry here. So we'll go put it in really quick. I think it's better to have it's better to do it the right way and go put these in rather than dimension or try and come up with some other hack that stays within the sketch. All right, so now we'll measure what our actual screw placing is off of our part. Two and 3/8. Let's see, 2 inches here. All right, there we go. Now this bracket only has 2 holes and this bracket has 3 holes. So I'm trying to think of some way to indicate that in the sketch. Like I like the fact that this has 3 points on it. And so maybe what we want to do is go in at the sketch, and instead of doing this point here and this length, maybe what we do is we do 2 points like this, make them vertical, set them vertical to this, and then do a symmetry line coming off of this here, and we make them 2 inches apart and symmetric about here. Yeah, that seems better, right? So now we know where these two, well, now we have kind of an indicator of, all right, this is 3 holes here, right? 1, 2, 3 points, and this is 2 holes here, 2 points. I think I like that. And it's little stuff like that, like on this part, okay, yes, are we over engineering this and spending extra time trying to make this perfect? Yes, but that's because it's a teaching tool, not necessarily a production part, or not necessarily what you would do for production. But yeah, I think doing little things like that where you can kind of make subtle indications as to, hey, what does this geometry do, right? How does this work? Like, it's going to only help you later on in 5 years when you go open up this part and make a change or copy it out and do a new version of it. You'll be able to look at sketches and look at stuff and kind of leave those indicators for yourself of how things go and where they're used and whatnot. So I think making a small change like this from the 2 lines, which obviously did what we wanted, but now we can more clearly see that, okay, this is, you know, this is 3 points, this is 2 points, those are all hole centers. I think little things like that go a long way. All right, one more thing we want to add in here, actually, now that I think about it, is we want to add a point on the origin, so that when we go to align it later as a derived sketch, we have an easy way to align that. So we could put 2 origins in technically if we knew that we wanted this bracket, that we were going to design it in the way where the center point was going to go through here. So maybe we do that as well. That would probably be fine to do, right? Like, okay, we want this to be a secondary option for the origin later, but we'll see. All right, so now we go back and we need to insert this derived sketch, right? So we'll edit this. We'll bring up this with top plane, insert drive sketch, right? And now we need to make sure that we, one, bring this up to the top of the tree so that everybody knows, hey, there's a drive sketch in this part, and that's controlling things. And then two, we need to control the geometry, or where the location of the sketch is. So make it parallel, right? Now fully defined derived sketch. So now we can go in here and we can do a sketch and we can say, all right, we want to bring in our holes, right? Like this. And then we can do a hole feature. Maybe we can't. That was weird. It's because I updated SolidWorks. Good old SolidWorks updates breaking stuff. So yeah, so it's now looking for the whole wizard for my 2023 version, and this is 2022. So instead of that, we'll just put in the holes manually instead of dealing with all that right now. So we'll just do something like this, drag this over, and go there. And then we'll just draw in our holes to revolve. Now, normally I'd just do a hole punch, but these are actually holes for flathead screws. So we'll hide this stuff here for now. And we'll draw our profile that we're going to revolve. So now we have to look up what the profile for the screw is. So based on the holes that we see, it looks like they're 1/4-20 flatheads, which means that the through holes, this is just off of a standard tap and clearance drill size chart. So a 1/4-20 screw needs a 266 through hole. And then we can look up so this is a screw data selector. So it's basically a chart that has a bunch of different information for different screw sizes. And then as you slide this stock in and out, it updates based on the size. So let's see here, we want a 1/4-20 flathead. So 153. So Quarter 20. Wait. Not a 1/4-20. So based on the hole, it's a 1/4-20, but based on the screw that came in it, it's a size 10 screw. So since that looks like they're just allowing a ton of play in their through holes. Okay. So they're just allowing a lot of extra play in their through holes for some reason, which is fine. And It's 285. So in that case, we can actually duplicate that since we're doing, since we're cutting the holes instead of using the hole feature wizard. We can actually make this custom hole size pretty easily. Yeah, looks like it's a 1032 then. 385, right? All right, cool. So we're gonna make this up here. $385. Whoa. And then included angle of 82. I wish it would give you double angle when it came over. Instead, we'll just do half the angle. Okay, and now we can start bringing in our derived sketches to locate this thing. Ooh. Interesting. Not sure why it's not allowing us to make that collinear. Makes me wonder if this is not perfect, if this sketch is not square where it should be. So we're gonna locate like this for now. And then we'll do the revolved cut. Yeah, looks like something's not quite right with maybe the way that this sketch got brought in. Should be parallel. The question is, are these two parallel, I guess? They are. So we'll go back to this base sketch and see what's up. Yep, that's horizontal. Ah, that's why, because I made this horizontal and it's not actually horizontal. So this is the link, and I shouldn't have done based off this link. I should have done it based off of this. So just that little bit of troubleshooting, right? We notice the behavior isn't quite what we want it to be or what we think it should be. And so we need to go in here, and you can see that I made this parallel to our top plane, which is not what we want. We actually want this parallel to our top plane. So there we go. All right, so I think we're going to use this as our pattern. Never draw something more than once if you don't have to. We'll do this. Geometry pattern. Selected point is there. Now we have a pattern across, and that's how we're using that. We have that sketch, that's sketch 9, right? Which is picking up the whole locations from our derived sketch 8 from up here. And then we're just patterning the our custom hole size across. So we don't have to draw that same feature twice, and we can control it through here, which is nice. All right, cool. I think that's gonna about do it for today. We'll come back through maybe this afternoon and finish detailing this out But I'm gonna get some lunch, and I'll see you guys back here in maybe, I don't know, 2 or 3 hours or so if you guys want to hang out. So thanks for hanging out with me. If this is helpful for you guys, please let me know. If you guys got any questions that you want us to tackle in future videos, leave those in the chat, and I'll see you guys in the next one. Thanks.